This Delta Math topic is over composition of transformations, shapes. Okay, so basically we're doing usually looks like 2 different movements on these, and they're going to give you a drop down. So they'll be like, did I do dilation or translation or reflection or rotation? Just remember, reflection is a flip. So we're usually flipping across the y-axis or our x-axis. Rotation is a turn, and I'll tell you how many degrees is it. 1 turn, so from one quadrant to the next is going to be 90 or 180, 270 or 90 or 180 or 270 or 360 back to, I don't know why I spaced out for a second there. Reflection, rotation, translation is the easiest one. So just for sliding left, right, up or down. And then dilation is the one where we squeeze it or we stretch it. And so if it's ever changing the same, if it ever changes size, it is going to be a dilation. So if it's bigger to smaller, smaller to bigger, pay attention. And also definitely every time any transformation, pay attention to what your starting point is. It's going to have the plain old boring letters. And then every time you make a change, you're going to get those little primes in the corner. So the starting point is the one with clean letters, okay? Clean, fresh letters, A, B, C, D. A, B, C, D, right there. So we're starting with our pink and we're going to our blue, which tells me I can tell you right away that there is going to be a dilation that happens because we went from big to small, okay? That is not the exact same. It's the same shape, but not the same size. That's similar, not congruent. So I know the dilation happens, and also, let's see here. Yeah, that's the only, yeah, that's all the rest of the info on this one. So you could do a reflection, okay, over the x-axis, and then a dilation can happen. It says here, determine a series of transformations. So series just means more than one. That gets you from A, B, C, D onto A prime, B prime, C prime, D prime. That's how you say that. It's so fun. It's like what math people do when they go out to dinner together. They just add prime to all the ends of their words. Just kidding. No, we don't. Okay, so what you do is you could reflect it. Okay, so we would reflect over our x-axis, and that's what it would look like. Think of that x-axis as a mirror, and you would go up the same amount as you would go down to get A to A prime. And then once you do that, you can draw that. Okay, or kind of point it out. If you have a dry erase marker, you can like write on your screen a little bit carefully. And then from here, you would do a dilation, right? So we're reducing. It should be a number less than 1 since we're getting smaller. And a quick trick to do that is look at corresponding sides. So like this side compared to this side, okay? The length is easy to count. It's 2 and it goes to 1. Well, what number gets me from 2 to 1? I have to multiply, okay? The scale factor is going to be smaller than 1. So 2 times what number is 1? You might be thinking, well, 2 divided by 2, Mrs. Landers, is 1. And when we divide by a number like 2, that's the same thing as multiplying by 1/2. Because look, you're taking your number, you're multiplying it by 1, you're dividing by 2. Multiply by 1, divide by 2. So it's the same idea. Okay, so if I had to divide by 3, if I was shrinking my shape by a third, okay, by 1/3. If I divided by 7, that's the same as multiplying by 1/7. I tell it to my students all the time, but for whatever reason, it's just so tricky. Okay, so a reflection over the x-axis and then a dilation by, in this case, 1/2, specifically that one right there. Okay. On this one, again, clean ABC to the A prime, B prime, C prime. Okay, what would we do here? Well, we would slide, okay, and then we could also dilate, and we can find a side that is easy to measure, nice straight edges. So that one was 3, and this one is 1. So how do I get from 3 to 1? You divide by 3, or you multiply by 1/3. Okay. So on that one, a dilation centered at the origin with a scale factor of 1/3. When it says at the origins or centered at the origin, that's all that we're doing in 8th grade math. So there are other times when you center a dilation around some other random point. That's high school geometry, not us. Okay. Followed by a translation left. Yeah. So you shrink it down and then you translate it. And then you're done. So much fun with transformations. Can't get enough of them.